Have you ever wondered what it actually looks like to teach a computer how to think? I'm not talking about just the theory. I mean the real deal, the actual lines of code that make it all happen. Well, that's exactly what we're going to do today. We're going to jump right in and walk through a real script to train our very first AI model from the ground up.
So it really all boils down to this one question. And you know what? The answer isn't some kind of magic, it's a really logical process called machine learning. Basically, we're just guiding a program to find patterns on its own, instead of us having to spell out every single rule.
So here's our game plan. It's a simple 6-step journey. First, we'll pick the kind of brain we're going to build. Then, we'll get its study materials, make sure there's no cheating, create the empty brain itself. Then comes the magic moment of training. And finally, we'll give it a final exam to see how it did. Let's get to it. All right, step 1, a computer that learns. So what kind of AI are we building? We have to pick a model. For our first go, we're going to use something called a decision tree. And I love starting with this one because, honestly, it thinks a lot like a person does. It just asks a bunch of simple yes or no questions to figure things out.
So check this out. This is literally the thought process of a decision tree. It's just a flowchart. The AI learns to ask these little questions one by one, like, okay, is the petal length less than 2.45 centimeters? If the answer is yes, boom, it goes down one path and decides it's definitely setosa. If the answer is no, it just goes down another branch and asks the next question. It keeps doing this until it lands on an answer. It's so simple, right? But this is a seriously powerful technique.
Okay, time to get our hands dirty with some actual code. This next part, gathering the study materials, is just like prepping to cook a meal. You got to get your tools ready, those are our imports, and you need your ingredients, which for us is our data.
So these first lines here are our imports. We're basically telling Python, hey, go grab these toolkits for me, I'm going to need them. So pandas, that's for handling our data. Think of it like a super-powered spreadsheet. Then, from scikit-learn, this amazing library, we're grabbing a few things. Load iris gives us our ready-made flower dataset, super convenient. Train test split, that's a really important one for making sure our test is fair. And decision tree classifier, well, that's the actual blueprint for the AI brain we're about to build.
Okay, now we put those imports to work. This line, iris equals load iris, does exactly what it says. It loads up this classic dataset full of flower measurements. But then, right away, we split it into two critical pieces. We use X, capital X, for the features. These are the raw measurements. You know, the petal length, the sepal width, all that stuff. And we use Y, lowercase y, for the target or the labels. Those are the correct answers, what species each flower is. And this split between the questions, X, and the answers, Y, is the absolute foundation of what we're doing here.
All right, section 3, the no cheating rule. And listen up, because if you take one thing away from this, it should be this. This is the golden rule of machine learning. You cannot test your model on the same stuff it used to study. Think about it. If you give a student the exact same questions on the final exam that were on the study guide, are they really learning or just memorizing? We need to know if our AI can actually think.
In this one line of code, this is how we enforce that no cheating rule. It's so cool. This train test split function takes all our data, both the features X and the answers Y, and it just shuffles them all up. But here's the key. This little piece right here, test size equals to 0.3, that tells it, hey, take 30% of this data and hide it, tuck it away for later. This creates our final exam that the model won't get to peek at.
I mean, the analogy is just perfect. The training set, that's the study guide. It's the textbooks, the homework, all the practice problems. It's everything our AI model gets to look at to learn the patterns. And the test set? That's the final exam. It's kept in a sealed envelope under lock and key until the very end. This is how we get a real, honest grade on whether it actually learned anything.
So for our particular dataset, what does that 70-30 split actually look like? Well, it means our model gets a study guide with 105 flowers to pore over and learn from. And then, for its final exam, we're going to hit it with 45 flowers that it has absolutely never seen before. That's a pretty fair test, right?
All right, section 4, creating the empty brain. Our data is prepped and ready to go. So now it's time to, well, create the thing that's gonna learn. But it's super important to get this. Right now, what we're creating is just an empty shell. It's a blank slate. It has the capacity to learn, but it knows absolutely nothing.
And would you believe it? This is it. This one single line is all it takes. We're telling Python, hey, that decision tree classifier blueprint we imported earlier, make me a new one.
and we're just storing it in this little variable called CLF. That's it. We've officially created an AI model object. Our empty brain is sitting there, ready and waiting.
So just to be super clear, when we say the model is initialized, it doesn't mean it's smart yet. Not at all. It just means the structure is there. It's like we've built the schoolhouse, but class hasn't started. The learning part, that's what's coming up right now.
Okay, deep breaths, everyone. This is it. Section 5, the magic moment. This is what it's all been leading up to. We've got our data split, we've got our empty brain. Now it's time to actually make it learn. Seriously, look at this line of code, CLF.fit. This is the absolute heart of machine learning. This .fit method is the go button. It's the command that tells the AI, okay, it's time to study. And notice what we're giving it. Xtrain, the practice questions, and Ytrain, the correct answers. We're literally telling our model, here's the study guide and the answer key. Figure out the rules that connect them.
And when you run that command, the computer just goes to work. It's churning through all 105 of those training flowers, looking for patterns. It's figuring out the absolute best questions to ask to separate the different types of flowers. It's building that entire decision flowchart we saw earlier completely from scratch, just by looking at the data.
And then, it's done. Once that line of code finishes running, which is usually super fast, that's it. You've officially done it. Congratulations, you have just trained your first AI model. That's the hello world of machine learning, right there. The brain isn't empty anymore, it is now officially trained. Okay, but here's the real question. Was it a good study session? A trained model is pretty useless if it can't actually use what it learned on new problems. So, it's time. Time to open that sealed envelope and pull out the final exam. Let's see how it does on that test data we've kept hidden this whole time. And this is the code for the test. We use the .predict method. Now notice the huge difference here. We're only giving it X-test, the questions from the exam. We are not showing it Y-test, the answers. That would be cheating. We're just showing it the measurements for those 45 new flowers and asking it, all right, smarty pants, based on everything you learned, what do you predict these are?
And here we go, the results for the first 5 flowers on the test. In the left column, that's what our model guessed. And on the right, that's the real answer. And just look at that. 1 for 1, 0 for 0, 2 for 2, it's a perfect match. That is awesome!
So what do those numbers even mean? Well, a 1 is a versicolor, 0 is a setosa, and 2 is a virginica. So our model correctly identified a versicolor, then a setosa, then a virginica, then 2 more versicolors, spot on every single time. It's passing this exam with flying colors.
And this brings us to the biggest takeaway of all. Think back through the code we just wrote. Did we ever write a line that said, if the petal length is small, then it's a sestosa? No way! We never hard-coded a single rule. All we did was give it examples, the data, and the answers, and that one little .fit command. And from that, it discovered the rules on its own. That is what machine learning is all about.
And that really makes you wonder, right? I mean, yeah, we just taught a computer to recognize flowers, which is cool. But this exact same process, this simple pattern of load, split, fit, predict, it's the same process used to teach a computer to spot spam in your inbox, to identify diseases in a medical image, or to tell a self-driving car the difference between a pedestrian and a lamppost. The only thing that changes is the data. So, if we can teach a computer to see flowers, what are we going to teach it to see next?